Right. So we're going to find the reference angle theta prime for each of the following angles. So for example A, I have theta equals 345 degrees. Everyone say draw a picture. You should always, always, always draw a picture. Let's do a quick review. Count with me in degrees. Class, this one is 0. This one? Over here?
270.
So we're drawing our picture for, we're trying to get theta, and then our answer, we're going to try to get theta prime, which is our reference angle. So as I go, positive angles, I want you to count with me how many degrees? 0. How many? Okay, I'm at 270 degrees, and I need to get to 345. So 345 minus 270 is going to give me what? $75 degrees. Right? 270 plus 75 gives me 345 degrees. What does that mean? That means that in this quadrant, a quadrantal angle is 90 degrees, so they're complementary. What's the complement of 75? Would be 15. So let's review. From standard position, 90, 180, 270, theta would be 345 degrees. It's in quadrant 4. That means this little part here is 15 degrees. Theta prime is 15 degrees. My reference angle is 15 degrees. Notice how this reference angle is both positive and less than 90. Now the reason why it's this side over here, it's 15 and not 75, is the bow tie. The bow tie basically looks like this, right? That's a bow tie. And it helps you form the triangle. That's very, very, very important. So notice how I'm not drawing my triangle this way. I'm going towards the x-axis, closest x-axis, and this is my reference angle. Okay? Let's go ahead and do that for the other example. Now, the second example is in radians. So pay attention. If it's in radians, you could use the idea of degrees to kind of help you, but don't be confused on it. Class, let's count in radians going around. Ready, set, go. Uh-huh. And okay. So I'm thinking to myself that this is pi over 2. And if you think about it, if you actually evaluated it, here I'll show you. Second caret divided by 2 just gives me half of that, which is approximately 1.57 radians. Okay, so this is 0 radians. Over here, we already know that pi is equal to what? 3.14 radians. But this one is 5 pi over 6, so I can do 5 pi, and then press enter, and then divide my answer by 6. This is 2.62 radians. So 2.62 radians is between 1.57 and 314. Think of it as $2.62, right? That's not between $0 and 150. It's between $1.57 and 340. So I know it's in quadrant 2. So I already have that idea. here's another way of figuring out where 5 pi over 6 is. So I don't really want you to convert into radians. I really don't want you to convert into degrees. You can do that. I'd rather use the fractions of the unit circle. What are the fractions? Well, this one says, change colors. This one says 1 pi. Well, how do I make 1 pi a fraction? Put over 1. And look at my denominator. My denominator is 6. So if I multiply by 6 over 6, I'm going to get an answer over here of 6 pi over 6. Does that make sense? So if this is 6 pi over 6 and this is 5 pi over 6, then I already know that my answer is somewhere here. So standard position, positive angle, rotated counterclockwise. This angle is theta 5 pi over 6. Well, think about it. I just need something now to complete it so I get 6 pi over 6. That means my reference angle, class, is how much? 1 pi over 6, or pi over 6. So, theta prime is pi over 6. And that should make sense because if you're going towards this quadrantal angle, I need 1 pi. So if you add those two, 5 plus 1 gives you 6 pi over 6. And then let's just draw our triangle. And how are we going to use that? Well, if I know that's pi over 6, or like a 30-degree angle, then I can start labeling my triangle.